Okay guys, now we're going to talk about 11.2, section 11.2, and we're going to go through all these examples today. They're very, very easy. Up until this point, every probability that we factored up using the relative frequency formula have been like mutually exclusive, and we've used the word or. Well, today we're going to talk about using the word and, okay? And that brings us to two definitions you kind of need to pay attention to, and that's being able to determine whether an event is independent or dependent, all right? And the way you will be able to figure that out is by the wording in your problem, okay? So, if you are doing a probability using the word and it says that it replaced something with replacement, then that is independent. If it says without replacement, so for instance, if you have marbles and it wants to know the probability of two colors, but you take one marble out, but you don't put it back in, your probability changes, okay? So if it says without replacement, then it's dependent, and we solve those a little differently. So follow me to 11.2a, okay? And we have our problem. It says, determine whether or not each pair of events is independent using the given information. All right, again, we know this by our wording. It says, a drama club had the following props: 2 trees, 3 bushes, 2 chairs, and 5 clouds. What is the probability of finding first a cloud and then a bush with replacement, okay? With replacement. We're not actually solving this time for probability. It wants to know, is this independent or dependent? With replacement equals independent, okay? Independent, there we go. Okay, now look at, this is an example of A. Look at B, okay? 10.2ab. It says finding first a chair, then a tree without replacement, okay? So without replacement, there's your wording, okay? Without replacement is going to be dependent. And why is it important that you can tell the difference? Because you solve the probabilities a little different, and that's what we're going to look at. Example 11.2b, but this is example 11.2a. Now we're looking at example 11.2b. It says, we're just going to jump right in because now we understand the difference between independent and dependent, and I'm going to show you how to solve for a probability using the word and in each of those, okay? So look at our problem. It says 8 marbles are hidden in a bag, 4 red, 3 blue, and 1 yellow. What is the probability of selecting 2 consecutive blue marbles with replacement? Okay, so it's 2 different events with replacement, so those are, that means it's independent. So what you do is you're gonna make kind of a little, just little notes to yourself, okay? Your first event, it wants, what's the probability of getting 2 consecutive blues? So the first time, the probability, how many are there? Well, there's 3. Okay, and if you take a blue out and you put a blue back in, then the second time you go to draw one out, there's going to be 3 again. So in each event, there's 3 blue marbles in the bag. That could be, those are your successful outcomes. That's how many times how many are in there, okay? So now we need our total outcomes, okay? So our total is, we're gonna add them up. 4 plus 3 plus 1, and that is 8, okay? 4 plus 3 plus 1 is 8. So there's 8 marbles total, okay? And your first event, you're gonna just come down and write it. What is your relative frequency formula for your first event? 3 over 8. So you just put 3 over 8, okay? And this is on page 507 in your book. Now, because this is this is like we are doing 2 we're going to go ahead and put a multiplication sign here. We're going to actually multiply the relative frequency formula for each event, okay? Now look, here is our second event. Our second event is another blue. What is the successful amount of outcomes for blue? Well, it's 3 because we put the blue back from the first time, okay? And then what is our total? Again, it is 8. Now, all you have to do is multiply straight across, okay? So this is 9, this is 64, and you want to change that into a decimal. 9 divided by 64, round it to however many places it tells you, 0.41, okay? And that's example 11.2b. All right, now we're going to look at 11.2c, and this is a little bit different because these probabilities are dependent. We're not replacing the one marble that we took out or anything your word problems tells you is being replaced, okay? So this is without replacement, and this is how you work it, okay? So look at your example. It says, suppose 12 candies are hidden in a bag, 7 red, 3 blue, and 2 yellow. What is the probability of selecting 2 consecutive blue candies without replacement? Okay, so when you take the blue one out, the next time you go to draw a blue one, you only have 2 in there. So your probability changes, okay? But watch, it's not that much different. So your first event, the first time you go to draw a blue candy, there's 3, okay? But the second time you go, because there's no replacement, there's only 2, okay? And then our total, if you add up all those candies, you don't even have to add them. Your book tells you there's 12, okay? So your total is 12. You've got 12 total candies, okay? So we're gonna set this up exactly like we did in 11.2b, but it's just a little bit different, and I'll show you how, okay? So your first event, there are 3 blue out of 12. That is your relative frequency formula, okay? So you would have 3 out of 12. The number of possible over the total, okay? Now, put your multiplication symbol there, because that's what we're doing, okay? Now, the second time you go to draw a blue candy, there's not 12 anymore because you didn't replace the one that you took out, and there's also, there wouldn't be that blue one if you were to get the blue one, okay? So your fraction changes, subtract 1 from each of these, okay? So you didn't replace, right? So now it's 2 over 11 instead of 3 over 12. And then multiply just like you know how, straight across. 2 times 3 is 6, and 11 times 12 is, well, I don't know. We could cross multiply because that's going to give me a big number. Let's go ahead and just go ahead and reduce our fraction. So this is going to give me 1 over 4 times 2 over 11, and then that's going to give us 2 over 44, which we can reduce that down to 1 over 22. And as a decimal, 1 divided by 22 is going to be 0.045. And that's example 11.2c. In our last example, we're going to look at 11.2d, and it says, suppose 20 candies are hidden in a bag, 9 are red, 3 are blue, and 8 yellow. What is the probability of selecting a blue candy and then a red candy without replacement? Okay, so remember, we are without replacement. This time it's not consecutive, it's 2 different candies, so I'll show you how that kind of changes your formula just a little bit too, okay? So your first event, what is it asking for? Okay, it's asking for blue, I think, blue candies. How many are there? 3. There's 3 blue. Your second event that it asks you for is red, so there are 9 red. Now, your first total outcome is 20. Your second total is 19, okay? Because you're not replacing the one that you drew out. But be careful, in your book, there's a typo. Okay, 11.2D, there's a typo. It says first total outcomes is 12. It's not, it's 20. Okay, all right, so that was a typo on their part. So anyways, if you look on down, there's not a 12 anywhere to be found. Okay, so there are 20 total, and you're going to take your first event. What is your probability of getting getting a blue one out of the 20? Well, just like we always do our relative frequency formula, we do 3 over our total, which is 20. Okay, go ahead and put your multiplication sign there. Now, look at your second event. Because it's a completely different color, we don't subtract from this one, okay? We're getting a different color. If we draw, it's not affected, so we go ahead and put 9, but we do have to subtract from the total because once we draw that first one, we don't replace it. So your fractions look like this, okay? You're going to go ahead and multiply straight across, and you're going to get 27. 20 times 19 is 380. Go ahead and divide 27 divided by 380, and you should get 0.071. And that's your probability, and that's example 11.2D.